Hey students, here's the review for Spiral 9. We're taking a look at some new topics from trigonometry as well as some old ones. Here's a reminder that you can use your review on your spiral, so please make use of that. First off, we got to do some graphing of sine and cosine, and when I take a look at this, I'm going to start by putting a couple graphs in here. So there's a nice graph. I'm going to decide my midline is +0, so that's my x-axis. And my amplitude is 1/2, so I'm going to go up 1/2, go down 1/2, and put some marks in there. Then we need a starting point, so that's going to be the inside. Which is going to be 3 theta is equal to 0. That means theta is going to be 0. I need an ending thing, which I'm going to do 3 theta is equal to 2 pi. Dividing by 3, that means theta equals 2 pi over 3. Okay, so that's my beginning and ending point. Cosine looks like this, so we're going to start at the top at 0. Okay, there's my value. I'm going to go to 2 pi over 3. I'm going to be at the top as well. Exactly between these two values is going to be that point. So between 0 and 2 is going to be 1 pi over 3. For cosine, that's at the bottom. I'm going to go exactly between those two. Half of 1/3 is 1/6. And that's going to be in the middle. And then we have to do a little bit more work to go between 1 and 2, but if you'd prefer, you could write this as 1.5, because that's exactly between those two, pi over 3. Or, if you would prefer instead, you could do that as 3 over 6, which you might recognize is 1/2. Here's my cosine curve. For the next one, we're doing the same thing. Got our graph. Midline's at -1. Amplitude is 1, so I'm going to go up to 0 and down to -2. Okay, another cosine, so that's our basic graph shape. And I'm going to do the same thing. So we've got theta over 3 plus 5 pi over 6 is equal to 0. I'm going to bring that to the other side. We get theta over 3 is equal to -5 pi over 6. It looks like I should have changed where my axis is, because if I multiply this by 3, we end up getting, well, that's going to be kind of nice, because those cancel to be 2 on the bottom. So I could do -5 pi over 2. For the other one, I'm just going to do this down below because I have room here. We got to set this equal to 2 pi. And because this is in sixths, I'm going to multiply this by 6 over 6. And that's going to make this 12 pi over 6, just to make that a little bit easier for us. So when I subtract, we end up getting theta over 3 is going to be 7 pi over 6. We multiply by 3, we get theta is equal to 7 pi over 2. So I'm going to put that on here. 7 pi over 2. All right, cosine, we said were the two top for our endpoints. Exactly between those two, we're going to end up at, if I add those, I get +2. Cut that in half, give me 1 pi over 2. That's going to be the bottom. Doing the same thing between 1 and 7, we're going to have 4. That's going to be on the midline. Between 1 and -5, we're going to have -2, which is going to be on the midline as well. So we get our nice cosine curve. At that point, we're done. Me with jumping pages. Next up, we got some trig identities. So we've got to manipulate these in order to make them look like the other side. I prefer to start on the complicated side, so we'll start on the left. And the first thing I'm going to do is to rewrite this in terms of sine and cosine. 1 over cosecant I could rewrite as sine squared of x. Tangent squared, that's in the bottom, I could rewrite as the reciprocal of tangent, which is going to be cosine squared x over sine squared x. And just to clarify with some colors, cosecant turns into sine, tangent on the bottom turns into cosine over sine. Alright, so now the next step, I notice I've got a sine on top and bottom, and I end up with cosine squared x is equal to cosine squared x. At this point, we're done. For the next one, we've got secant squared minus cosecant squared is equal to tangent squared minus cotangent squared. Doesn't really matter which side I start with here. If I take a look at my identities, I notice I've got secant squared, cosecant squared by itself, so it might make sense to start on this side. So secant squared, using what I just underlined, is going to be tangent squared plus 1, and then we're subtracting cosecant squared, which is 1 plus cotangent squared x. I also forgot my x in my tangent squared. Bad tangent there. Okay. So I've got plus 1 and minus 1. Those cancel out. Just tangent squared. And then we're minusing from that cotangent squared, which is what we're trying to get here. So at that point, we are done. Alright, so next up we've got sum and difference angle identities. These are written on the side for you. For the first one, I've got sine of theta plus 180, so let's just use the positive side of this. That's going to be sine theta, cosine of 180 plus cosine theta, sine of 180. Grab your unit circle, take a look at what those values are. Cosine of 180 is going to be negative 1. We got sine of theta. Sine of 180 is going to be 0. We got cosine of theta. That cancels to 0. We're left with negative sine of theta. Right, for the next one, I'm actually going to take a look at the right side of this, because that's a little bit more complicated to me, and I'm going to use a double angle identity. I've got cosecant, which goes with sine. So maybe I'll take a look at that one, which is going to be cosine of 2 theta. Actually, you know what? This one has both sine and cosine. Maybe I'll use that one. So we've got cosine squared x minus, and here's where we're plugging in, cosine squared theta minus sine squared theta. When I do that, my cosines cancel out, and we got negative negative is positive sine squared theta. Sine squared theta is the same as 1 over cosecant squared theta. That's what we're trying to get. And at that point, we have finished this problem. Alright, next up we got to use some double or angle sum identities in different ways. If you're given something in twelfths, what we really want to do is to think about this as cosine of something pi over 12 plus something else pi over 12. Now I want to do this in a way that's going to let those reduce. So I'm going to choose 8 and 3 because both of those reduce in here. That gives us cosine of dividing both of those by 3, 2 pi over 3. By that I mean dividing both by 4. Then for this one, dividing both by 3, we get pi over 4. Okay, you're going to use your unit circle for this once we break these things up. So cosine of a sum is going to be the top here, so minus. It's going to be cosine of 2 pi over 3, cosine pi over 4, minus sine of 2 pi over 3, sine pi over 4. Cosine of 2 pi over 3 is going to be negative a half times root 2 over 2 minus 1/2 times root 2 over 2. When I combine those, I actually just screwed that up. It should be root 3 over 2, not 1/2. Okay. Thanks for the little bit. Okay, we end up getting negative root 2 over 4 For the second part, root 3 times root 2 is root 6. For the next one, doing the same thing, we try to figure out what was going to add up to negative 7. Or maybe even subtract to negative 7. Like, I don't know, if we had maybe 2 minus 9. That's going to be pi over 6 minus 3 pi over 4. Using my formula up here, we've got sine of pi over 6 cosine of 3 pi over 4 minus cosine of pi over 6 sine of 3 pi over 4. So plugging this in, that's going to be 1/2 times the negative root 2 over 2 minus root 3 over 2 times the positive root 2 over 2. Gets us negative root 2 over 4, and then minus root 6. It's exactly what we had in the first one. For the next one, we got to do a little bit more work. We got to find cosine of 2 times an angle when we're given tangent. We're also told that this is between pi and 3 pi over 2, so we're down here somewhere. If this is 8 over 15, that means that the opposite over the adjacent would be 8 over 15. That happens to be Pythagorean triple. It's going to be 8, 15, 17. So that's going to be our hypotenuse. Okay, cosine of 2 theta. I can choose any of these ones. It doesn't actually matter. I might choose the first one just because that's there. So I need cosine squared of theta minus sine squared of theta. Cosine is going to be, those should both be negative. Cosine should be 8 over 17 squared. That's going to make that positive. So 64 over 17 squared, and then we got minus sine of that. I like how I just did that. It should be 15 squared. There we go. Sorry about that again. Because sine is going to be the y value. 8 squared over 17 squared. That's going to be our value. You can do that out, and that'll be it. So just for funsies, that's going to be 225 minus 64 over 289. 225 minus 64 is going to be 161 over 289. For the next one, we're looking between 0 and pi over 2, so now we're in the first quadrant. 15 over 17, so that's going to be 15, 17. Happens to be the same triangle we just had. That means x is going to be 8. Those are all positive. Sine of 2 theta is going to be 2 sine theta cosine theta. So we've got 2 sine theta would be, oh, we already have that. 15 over 17. Cosine over theta would be 8 over 17. That's going to be 2 times 15 is 30, times 8 is 240, over 289. Then finally we got some solving equations. I'm going to try to gather all these things on the same side because I've got some potentially factoring stuff going on. I'm going to add 3 sine squared to both sides. And I noticed that both of these have a sine theta as part of that, so I'm going to factor out a sine theta. Alright, let's take each piece of this separately. So we've got sine theta is equal to 0. You're going to use your unit circle for this. And you find out that the y is 0 and at pi. For the next part, we got root 3 plus 2 sine theta is equal to 0. Getting sine theta by itself, I'm going to end up with negative root 3. Divide that by 2. That's going to happen at our 2 third and fourth quadrant angles, so that's going to be 4 pi over 3 and 5 pi over 3. On the other side, I've got both cosine and tangent. Maybe I'll combine everything on the same side again. So I'm going to add 3 cosine to the other side. So that's going to give us cosine theta plus cosine theta tangent of theta is equal to 0. Okay, that's factorable. So we get cosine theta times 1 plus tangent of theta is equal to 0. Cosine theta is equal to 0. That happens at pi over 2 and 3 pi over 2. Again, please use unit circle for that. And 1 plus tangent of theta is equal to 0. That means tangent of theta is equal to negative 1. We're looking for places that tangent has equal but opposite signs. That happens up here and down here. And our 2 root 2 over 2 angles. So that gives us at 3 pi over 4 and at 7 pi over 4.